Welcome to Introduction to Computer Networks Part 2. Let's begin. You have a communication network like this and you have two devices A comma B. Now the question is how A can forward its message M to B. I would like to talk about the technology part. Okay. Now, so that technology is called switching. Switching can be done in so many ways. One popular way is packet switching. I would like to talk about packet switching. Okay. In packet switching, your message is divided into some tiny units called packets P1, P2, P3. Now after that, each router forwards its packets independently. Example, let's say A has this packets P1, P2, P3, right? Let's say they are forwarded to R1. Now R1 has a choice. So R1 can forward P1, P2, P3 independently based on its routing algorithms. So that is called packet switching. Packet switching is very popular model in computer networks. So because of that, what can happen is P1 can be forwarded here and P2, P3 can be forwarded to R3 router. Now, so R2 will forward that packet to R5. R3 may forward these packets P2, P3 here. Okay. Now, R6 because it has only single link, then again it will forward P2, P3 here. Okay. Now P1 eventually will come here. What if R3 is connected to R7? Then this P2, P3 might be forwarded like this: P2 here and P3. Okay. Now, so this P3 slowly will come and it will eventually will reach this router. Then this router will forward P1, P2, P3 to P. So that is the way packet switching works. Now here one important property I would like to talk about. It's obvious that P1, P2, P3 might come to be in unordered, right? So that is one thing. So what to do then? Then we need a functionality called assembling, right? So assembly, reassembly otherwise. Correct. Here what are you expecting at end? So B has to assemble these packets, that's it. So second thing, this should have a mechanism to understand what is the first packet and what is the last packet. Then only assembly can be done properly, right? Yes. So that is about packet switching. Let's see one more problem. Let's say A is sending all its packets P1, P2, P3, P4, P5 to B. In this process, let's say they initially arrive to R1. Now R1 using its dynamic routing algorithm decided to send all its packets to through this path. Okay. Similarly, R4 using its algorithm decided to send all its packets through this path. Okay. Now R6 selected this path. R8 selected this path. Okay. We don't know the reason. So what happens you see now? So initially P1 will come here, correct? Then. So while R1 is processing P1, P2 might arrive to R4. Then what R4 has to do? Then P2 should be buffered, right? Or discarded. Discarding is not a good idea. Then it has to be buffered. Assume that let's say R4 has enough buffer, then P2 will be buffered. What while processing P1, P3 also comes, then P3 has to be queued, correct? Now I can say that P3 or P2 are suffering a delay, correct? Then imagine this situation, while still P1 is getting processed, what if P4 comes? Then again in the buffer, then P5 will be in the buffer, then P5 will see a tremendous traffic, correct? So that's why, so this is called congestion, right? So this entire path is called congestion path. Then we have to avoid that congestion. Sir, why don't we balance the load? That means, we send one packet to this direction and another packet to this direction and another packet in this direction. In that way, we balance the load. Yes, you can do it, but like you need some algorithm for that, right? A systematic way. So that we will be studying. So congestion algorithms we'll see like how to control the congestion. Okay, that's a big story. We will study that. Apart from that. Now see this story. You have let's say two systems A comma B. So far you thought the communication is between exactly A and B. But if you go into details, actually it is particularly between application to application. A1, A2, A3 are the three applications in A. B1, B2, B3 are the applications in B, let's say. Okay. Application means like WhatsApp is an application and Facebook is an application. Okay. So this WhatsApp application specifically wants to communicate with B1, which is another WhatsApp application in B. Okay. So now if you have just IP addresses, assume that let's say XYZ is IP address of A, ABC is IP address of B. If you simply send a packet like this with address XYZ and ABC and data, okay, if you send it, then probably because of destination address ABC, it might reach system B. But there are three applications which are currently active, and every application might think that this data is for them, right? So there is an ambiguity. To avoid the ambiguity, sir, before that I have another question, sir. What is that? Sir, why XYZ? Because this destination should know who is the sender, right? Then he can communicate back, right? That's why. So source address also will be mentioned. We will see more details when we study the particular topic. So don't worry now. So now source address and destination address. Along with that, we need two more addresses. Why? For specifically mentioning this B1, correct? That's why port address is introduced. Port address. Every application will have a unique port address. Okay, let's call small a1 as a port address for capital A1. B1 application's port address is B1. Then we are going to mention A1 comma B1 along with XYZ ABC for a unambiguous communication. Because of that, what happens whenever this packet reaches here, then because of ABC it will come here. Because of B1 it will reach a particular application. This is the way we are going to solve the addressing problem. Now we'll see one more important concept in computer networks, that is network security. Example, A is sending data to B through a network which is vulnerable. That means this thief can cut the cables of that network and get the data. In that situation, how A and B can have a safe communication is the question. So for that we have so many solutions. At application level, what we can do is we can encrypt and decrypt the messages. Example, A is going to encrypt the message and he is going to send it through the network. So we have to design the protocol such a way that A can encrypt, B can decrypt, but thief cannot decrypt it. Okay, only B can decrypt it. Such a way we have to plan. So that's a trick of cryptographic algorithms we will study extensively. Fine. So these are all various ideas we are going to discuss in computer networks. We will see one by one. In this lecture we talk about basic terminology related to computer networks. Let me begin with data flow. A and B are communicating. So data will flow, right? Then how many different ways data can flow? One is simplex, second one half duplex, and third one full duplex. Let me begin with simplex. If the data flow is simplex, that means only one can send and one can receive. Example, let's say A can send and B can receive. That's it. So strictly I can say that A is the sender, only sender, and B is the only receiver. So I can show like this. The data direction is like this. B cannot send data to A, only A can send. That is simplex. In half duplex, either A can send to B or B can send to A, but not both at a time. That means maybe in the morning A can send the data to B. Okay. In the evening, B can send the data to A. So this kind of communication is called half duplex. So when A is sending, B cannot send. When B is sending, A cannot send. So third one is full duplex. In full duplex, A and B both can send the data and receive the data like this. So we can show like this. So A can send the data, at the same time B also can send the data. That's it. So this is about various different data flows. Now we'll talk about physical structures. So physical structures is all about connections, how devices are connected. Let's begin with types of connection. A connection between systems can be either point to point, otherwise multi-point. Let's see that. So point to point connection looks like this. There is a dedicated link between the systems. So only A and B can use this link. So whenever A sends the data, it will reach only B. That is a point to point link. So if this link is idle, that means A and B are not using, other system cannot use it. That's one important point. So second one, multi-point. In multi-point, what happens, multiple systems like A, B, C, D, they share the medium like this. So you can imagine like this. Okay. So now all this A, B, C, D can use this medium. Maybe sir, how they use, there are various techniques. One is like they can share the time. Okay, so maybe for 5 minutes A can use, after next 5 minutes B, next 5 minutes C, next 5 minutes D. This is one way. There are other ways, so we will see that later. So especially when I teach you Ethernet technology, I teach you another way. So remember, whenever the communication medium is shared by the multiple systems, then we say that is multi-point connection. There is no dedicated link between the systems. If A wants to send data to B or C or D, then he has to go through like this. So that is multi-point connection. Now we'll see physical topology. This is about how the structure of the communication network. So you can connect the systems in these ways, like mesh topology, star topology, bus topology, ring topology. We will see one by one. Example, let's say you have 4 systems A, B, C, D. So we say that if you connect every system to every system using, let's say, dedicated link point to point like this, A to C, C to D, B to D, A to D, B to C, then we say that so you are having a mesh topology. Fine, that's it. What is the advantage of that? This is robust. That means if there is a damage in the connection between A to B, that will not disturb other connections. Still A can send to D and A can send to C. C and D can communicate in that way. Only that particular communication will go off, right? So that is one thing. Second thing, one more important thing you can see, it's costly, isn't it? See, lot of cables. If you have 10 systems, then how many connections are required? If you see, between every 2 systems there is a connection, right? So between 2, that means if you have 10 systems, then 10 C2 connections are required. In discrete math, I have explained you, this is a complete graph. The number of edges in complete graph equal to n into n minus 1 by 2, remember. Right? Here, that's why it is 10 into 9 by 2. 45 connections are required. Imagine you have 100 systems. Then how many connections are required? 100 into 99 by 2, right? So very large number of connections. Because of that, the cost will be very high. So in colleges and universities, that's why we don't use this mesh topology. And generally we don't require that many connections too. So that's why we go for another technology, that is our topology, star topology. In star topology, what happens, we'll see. There will be a hub like this. Hub will have ports. Each port is used to connect one device like this. A will have port here. So this port and this port will be connected. A, here B, here C and D. Okay. So here you can imagine communication cable. Whenever A sends the data, first it will go here. Then this hub will relay that data to B, C, D. Then appropriate system will take it. So that means data comes like this and like this and like this. Similarly, when B sends the data, then it will be relayed to A, C, D. So this is called hub or controller. Now, if you see the connections, definitely the number of connections are drastically got reduced, right? So here it would be 10 into 9 by 2, 45. But here to connect 4 systems, then after all you require 4 connections. That's it. That is the advantage of this star topology. Fine. Now, example, let's say if there is a problem in this connection, still no problem, right? Still BCD can be communicated. The only problem with this hub is like what if the central device get corrupted, then ABCD cannot have any communication. So that's why this is very important. So this cannot be corrupted. Such a way we have to plan it. Now the third one is bus topology. We'll try to understand bus topology. In bus topology, there will be a long cable, and we are able to cut that cable and we can connect a system. Okay, this is called tap. Similarly, we can have so many taps. At this point, we connect the system. A, B, C, D. So whenever A wants to send the data, it will send like this. So the data or signal comes here. After that, it will be passed through all over the cable. That's it. Similarly, B can send the data and C can send the data, D can send the data. But you can easily understand that A and B cannot send the data at a time. Here also in hub also same problem. So when you have A and B, in star topology also same problem. When A and B at a time wants to send the data, then there will be a collision. So how to avoid the collision, that we can see. Okay, we have technology for that. So similarly in bus also there is a collision problem, we can avoid it, but you should just see the topology. So that in this topology the number of connections are again 1, 2, 3, 4, right? And one more advantage of this bus is, like example, let's say this is your college. Okay, you have various departments, and systems are distributed like this. Then you can have a cable like this. You can lay a cable like this. Fine. Now, so at nearest point we can tap like this. So each system will tap the main cable like this. So this is all about bus topology. Fine. Now we will see the ring topology. Ring is introduced by IBM. So IBM has a technology called token ring. In the token ring, the network topology is ring topology. We'll try to understand that. Of course, in the gate we don't have that in the syllabus. So that's why we just quickly close it. So in ring topology what happens? This is your cable. So all the systems are connected like this. Right. Now the idea of that's it. This is ring topology, and signals will be transferred like this. Example, A wants to send the data, it will send like this. Then it will come like this. Once it makes a rotation, then the signal should be drained. Okay. So A has to open this cable, and it has to be drained. Remember it. Now, but who has to send the data? A or B or C or D or E? There will be a collision, right? Here also there is a collision problem. To avoid the collision problem, then there is a concept called token. Token is a signal which always revolves around this circle. So whenever B wants to send the data, the token has to be acquired by B. So everyone will try to acquire the token. Whoever gets it, then the token will be drained. So token will be removed from the cable, and then data will be sent. That's it. Once data is sent, then B has to release the token. The same example, token is nothing but signal, okay, some pattern. Same pattern should be regenerated. Then again other systems will start acquiring it. Once they acquire, they will do the same. So this is about ring topology, and we don't need much details about it. But if you see here, mesh topology has lot of connections, and star, bus and ring have less number of connections. So no one is using nowadays ring topology, but star and bus are very popular topologies we use in various places like Ethernet and all. We will see that. Okay. Now we'll see categories of network. We have three categories: local area network, metropolitan area network, and wide area network. So this classification is based on the size of the network. So how big it is? So generally local area networks are networks which are owned by colleges and universities or individuals, and generally spans over few kilometers, maybe around 2 to 5 kilometers in that way. So 0 to 5 kilometers. So here the technology, generally to implement this kind of local area network, we have Ethernet and Wi-Fi. So these are the technologies we use to implement local area network. Metropolitan area network. So generally this is a network which spans over the city. Example, let's say you have a local area network here and there. Okay, so which are separated over 50 kilometers or 100 kilometers like this. Then we need a different technology than Ethernet and Wi-Fi. They won't work. So we form a different technology, and we form a different network, that is called metropolitan area network. Third one, wide area network. In wide area network, so generally one thumb rule is, like wide area network, in that systems are separated over thousands of kilometers. That means your network spans over even countries and continents. Maybe like this. Example, let's say you have a router in India, another router in America, okay, and you want to send the data from one router to another. Then see, almost greater than 5,000 kilometers data has to travel, right? That's a big problem. For that, this kind of Ethernet technology will not work, and the technology which you use for metropolitan area network might not work. So we need a different thing. So here the technology we use is ATM and frame relay. Even there are hundreds of such technologies. Okay, so these are the popular technologies people use to send the data from one node to another node. So generally it's like relaying the data. simply, so all the signals will be simply relayed. So of course we don't want to talk about that technologies here, but you just see the major outline, basic outline. Local area network that spans over few kilometers, metropolitan area network generally spans over, within the city, and wide area network generally, spans over across the cities and countries and even continents. Now we'll talk about protocol. So what is protocol? Because we are going to study a lot of protocols. Before that, you should know what this protocol does. What are the main things we have in that protocol? Generally protocol will have syntax and semantics and timing. We will see one by one. Syntax. Example, let's say A is sending the data. This is a message. So if this message is divided into some sections, first 32 bits source address, second 32 bits destination address, so on. Now the question number one, why we have to do it, sir? If you don't do it, then the first problem is like router cannot understand where is the destination address, then how you can forward? So that's why we should know where exactly destination address is placed, correct? So that's why syntax is important. Second one, semantics. We have to mention that what is the meaning of each section of data. Example, here if you write 01010101, so what is the meaning of this pattern? That should be specified. So protocol has to specify the semantics. Okay, that means each meaning of each section of data. Third one, timing. So timing is about two things. One is like when to send the data, because receiver should be ready, right? So when to send the data. Second thing, how fast we can send. So protocol has to specify the timing, like when to send the data. If device is not ready, we should not send. Second thing, how fast we can send the data. Example, A is sending the data with 100 MB per second speed, but receiver can receive only 1 megabyte per second. Then what happens? Then definitely the sender is going to overwhelm the receiver with huge data, right? Then only thing B can do is buffering it. But if B has a limited memory, then after some time what happens? That buffer will become full, and after that B cannot take the data from A. That's why A should know how much data he can send to B. So that's why timing is one more important thing in protocol. So this is about protocol. Now finally we understood some of the basic terminology related to computer networks.